Hello, I am Dr. C. Christie, Assistant Professor from Computer Science Department, St.Joseph's College of Arts and Science, Autonomous Cuddalore 1. This video, let us see about object-oriented design process and design axioms. Object-oriented design process consists of the following phases: design classes, methods, attributes, and association. Next, apply design axioms and refine UML class diagrams. Next, design, view access layers and build a prototype. In access layer design, we have to create mirror class, identify access layer class relationship, simplify classes and the relationship, remove redundant class and method class. Finally, we have to perform user satisfaction and usability test based on use cases. Each and every phase is an iterative process. Object-oriented design axioms and corollary. Axioms are common truth, always valid, and no need to prove and derive. It is hypothesis from observation. Theorem can be proven from axioms. Corollaries follows from axioms and theorems. Axioms for object-oriented analysis and design. An axiom is a fundamental truth that always observed to be valid. There is no counter-example or exception. The axioms cannot be proven or derived. A theorem is a proposition that may not be self-evident, but it can be proven from accepted axioms. So, it is equivalent to a law or principle. There are two types of axioms, axiom 1 and axiom 2. Axiom 1 is associated with independence and axiom 2 is associated with information. An independent axiom is used to maintain the independence of components. Each component must satisfy the requirements without affecting other requirements. The information axiom is used to minimize the information content during the design process. For minimization, inheritance concept is used. Corollary. It is called design rules and derived from axioms. There are 6 types of corollaries named Corollary 1 to Corollary 6. Each and every corollaries are associated with following concepts. Corollary 1, uncoupled design with less information content. Corollary 2, single purpose. Corollary 3, large number of single classes. Corollary 4, strong mapping. Corollary 5, standardization. And Corollary 6, design with inheritance. This diagram shows the association or interaction between 2 types of axioms and 6 types of corollaries. The axiom 1 is associated with corollary 1, 2, 3 and 4. The axiom 2 is associated with corollary 1, 2, 3, 5 and 6. Next, we will see the above 6 types of corollaries in detail. Corollary 1. Uncoupled design with less information content. It minimizes cohesiveness, improve coupling, the less information transaction between objects. Coupling deals interaction among objects. There are 2 types of coupling, interaction and inheritance coupling. The interaction coupling involves the amount and complexity of messages between components. The tightly coupled object leads to change in one object that reflects the changes in others. Inheritance coupling. It is the form of coupling between super and subclass. High inheritance coupling is desirable. Cohesion. It deals interaction within a single object. It reflects single purposeness. High cohesiveness can lower coupling. Corollary 2. It is mainly based on single purpose. Each class must have a single purpose or some purpose. It clearly defined and necessary give the context of achieving system's goal. Corollary 3. Large number of single classes and reusability. The smaller classes are less specialized and chance of reusing. The large and complex classes are more specialized and less chances of reusing. The less specialized classes are more likely to be used in future problems and that can be solved by a recombination of existing classes. Corollary 4. Strong mapping. As the model progresses from analysis to implementation, more detail is added, but it remains the same. Strong mapping links classes identified during analysis and design phase. Corollary 5. Standardization. Documentation. It gives the knowledge of existing classes and helps to identify new classes. Corollary 6. Design with inheritance. The common behavior must be moved to superclass. The superclass subclass structure must make logical sense. Thank you for watching this video.